Hello, everyone. We will be starting with the session now. Dear authors and invited guests, welcome to Technical Session 7A. My name is Deemahi, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Intelligent Systems, Bangkok, Thailand. The 11th edition of the conference is being organized in a hybrid mode. The physical event will be held today in Bangkok, and the virtual event is being held through Zoom from 9th to 11th April 2026. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for presentation and 2 minutes for question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Now, before we proceed, I would like to introduce you all to the chair of the session. We have with us Professor Michael David. Dr. Michael is an associate professor in the Department of Telecommunication Engineering at the Federal University of Technology, Minna, Nigeria. With around 20 years of academic experience, his research focuses on optical communication and Li-Fi, optical sensors and spectroscopy, mobility management, and computational engineering, contributing to advanced communication systems and emerging technologies. A warm welcome to you, sir, and I request you to share a few words with the presenters today. Michael, sir, you are on mute, sir.
Am I audible now?
Yes, sir.
Hello. All right. Good morning, distinguished colleagues, professors, and fellow researchers. It is my pleasure to welcome you to today's session, where we will explore cutting-edge research across diverse range of fields, including artificial intelligence, IoT security, environmental robotics, healthcare analytics, digital media visualization, smart energy systems, and web accessibility. As we engage with these presentations, I encourage everyone to think critically, ask insightful questions, and consider how these findings can inspire new directions in our own research. Without further ado, let us begin our session and explore these exciting contributions. Once again, welcome and thank you.
Thank you so much, sir. We also have with us Dr. Sandeep Thorat for chairing the session. Dr. Sandeep is the Controller of Examination and Teaching Faculty at Government College of Engineering, Karad, Maharashtra, India. His research areas include educational assessment, academic administration, and engineering education systems. He is actively involved in examination management, academic governance, and institutional development in technical education. Welcome, sir, and please share any introductory remark for the presenters.
I extend warm thanks to organizers and my fellow colleagues who have gathered over here. I wish good luck for all those who are presenting today. This is a good forum for all of you to present your learning experiences, what you have done, novel part in your academic journey or maybe in industrial life. All the best. Wish you all good luck. Thank you.
Yes, thank you, sir. Now we will be starting with the presentations. First up, I would like to call Senthil Kumar Selvaraj to present his study on a design and study of DTMF technology enabled water surface cleaning robot.
Yeah, thank you, ma'am. Good morning to one and all. Ma'am, can I share my PPT?
Yes, sir.
Yes. Okay, it's visible, ma'am.
Give us a moment, sir. Yes, sir, we can see your folder screen.
Okay, yes. Just a minute. Yeah, now it's visible.
Yes, sir.
Yeah, yes. So, good morning to everyone. I am Dr. Senthil Kumar Selvaraj. I'm working as assistant professor in Vienna Village Engineering College in Hyderabad, India. So, today I begin to present my project work as a design and study of the DTFM technology enabled water surfacing cleaning robot. So, first of all, why we need the water surfacing cleaning robot? So, nowadays, the all rivers and the lakes, a lot of pollution has happened. So it's using the human power to remove all wastages from the rivers and the lakes. It's very difficult and then it's very dangerous also. So that's why we're just introducing the water surfacing cleaning robot. So we just control the robotic model with through the mobile phone using the DTM of the technology. So this is proposed robot is remotely controlled to a mobile phone via DTM of signals. So each and every buttons in our mobiles, each numbers have the two type of the frequency signals. Okay, so low frequency and higher frequency also. So combined the frequency, we will get the unique frequency signal. So based on the signal, the robotic model will move and then it will collect the wastages from the lakes and rivers also. So we using the conveyor belt with filter mechanism to collect the floating wastages in the rivers or lakes. So this is the automated and the safe solution for the, we are giving the solution to collect the wastage from the rivers. So it's not a human powers is not required to collect the wastages. We're using this simple robotic system to collect the wastages from the rivers and the floating, especially the floating wastages from the rivers and lakes. So in this DTM of technology, so we are using the PIC microcontroller to control the robotic system, and then the robotic model, we are using the DC servo motor to move one place to another places. So we can control the DC servo motor using the motor driver also. So DTMF communication using the mobile phones. If you press the button, automatically the robot will move forward, backward, and left and right. Based on that, it will move nearby the wastages and it will collect. And we have the separate storage tank in our robotic model. So it will collect the wastages and store in the storage tank, and then again it will come to the initial point. So in this DT technology, so this is a dual tone multiple frequency telecommunication method. So we have one is the low frequency, another one is the high frequency. So this is the 4x4 keypad matrix. So if you collect the rows, for example, you just see the table. So in these rows, it will mention the low frequencies, and column it will mention the high frequency ranges. So if you press the button 2, the robot model will move forward, and if you press the 4, automatic robotic model, it will move left hand side, and 6 right hand side, and 8 is the reverse, and then the rolling belt collects the floating wastages from the river. So in this 4x4 keypad method, we are just using the mobile through the mobile phone. You can control the robotic model to collect the wastages, and then this is the control system. How to control the robotic system? The control part is very important in robotic model. So without the controller, we can't control the robotic motion. So we are using the PIC microcontroller. You just giving the signal using, we are using the ultrasonic sensors also to detect the obstacles, and then it will avoid the obstacle and move forward. And then the reset button, you can reset the robotic system in case if you're having any issues in between. So you can reset the robotic model, and then again you can operate to collect the continuing the process. So the process, a microcontroller, it will control the robotic model. The motor driver operates the DC motors to move the robotic in different direction based on your signals. So and then the programming and debugging tools, the picket is used for the electrically erasable program. Okay, so this is the EEPROM, so read only memory. And then the microcontroller programming, debugging, and improved designs also we are introduced. We are just identifying the robotic model, where's the location using the GPS technology. So we identify the robotic model, and then you can control in between the frequency ranges. So we are using the some open source software, virtual robotic experimental platform simulation software. We done the more testing using the simulation softwares also. So you can design any kind of the robotic model in using the VREP software, and can design like mobile robot, and then what kind of the robot, industrial robot also you can design using this software. So we just designed a robotic model using this simulation software platform, and then we just tested in simulation time, part also, and then the robotic movement was analyzed using this particular VREP software, and 3D motion analysis also, motion simulation part also be analyzed. And particularly the robotic model supports up to the 4 MB memory. So this is significantly higher than the PICKIT. So this is our robotic model. So we developed the prototype model. This is not the small prototype model we just tested in our nearby the lake and rivers, and then we're using cameras to identify the wastages, and then we are using the DTMF technology to move nearby the wastages, and then we collect the wastages and then store in storage tank. So this is the main purpose we developed the model for the human safety, because we're using the human powers in lake and rivers. There are some it is not safe for us. We are facing some critical situations, so that's why we are trying to avoid the situation, and then we will collect the wastages from the rivers and lake. So we just introduced this prototype model. And what are the final conclusion? In this particular robotic model, you can use this DTMF technology robotic system. We just control the robotic model in shortest distance only, and then we can increase the frequency ranges to control the robotic model, so up to 100 or 200 meters also, and then you can control the robotic model using the unique signal. So I already told you, in DTMF technology, you just using the unique signal. Each and every numbers have the unique signal, high frequency and low frequency ranges also. So combined to the high and low frequency range, we have the unique signal for each and every numbers. So if you press 2, 4, 6, 8 numbers, you can control the robotic model up, down, left, and right, and then you move nearby the wastages and collect the wastages, store the tank, and then you just clean the river, and then the floating wastages from the lakes. So this is the very low risky, and then you can save the time, and then this is a low cost prototype model we are introducing. Maximum it will not take more. It's not if you more efficiency. This is the, what do you say? It not need to spend more money to develop this model. You can use small kind of the components, and then you can develop the simple prototype model. Okay. So and then the payload we are just tried to payload up to the 5 kg from this robotic model. You can, if you want, you can increase the payload, and then you collect the more wastages from the water surface. Okay. So thank you to everyone to give the opportunity to me. So do you have any queries? Please ask.
Michael, sir, any questions?
Yes, just one question. Thank you very much, Doctor, for your successful presentation. My question is,
Yes.
there are several other wireless control methods.
Yes, sir.
Why did you decide to choose DTMF technology?
So DTMF technologies, we are just controlling the robotic model, because if you are developing the autonomous robotic model means, in case if you're having any issues in between the process, we can't do anything. This is the autonomous, completely the autonomous. But if you are using the DTMF technology, you can control the robotic model through your mobile phone. So if you have any issues, you can reset your robotic system. Again, you can the robotic model reach your station also.
All right, thank you very much.
Yeah.
Sandeep, sir, any questions?
Yeah, first of all, congratulations to the authors for presenting your paper over here. I
Yes,
have
sir.
a couple of questions. Have you done the literature survey on this topic and identified what are the existing methods, probably what are the gaps in that existing methods?
Yes, sir. Actually, previously researchers, they have developed the model using some what do you say? They are using joysticks like that, the remote control to control the robotic system. But we are introducing the DTMF technology in this particular model, so you can control the robotic model through your mobile phone. Alternate told this is the unique frequencies we have.
So the gap identified was that earlier methods we were not able to control through mobile phones.
Yeah.
And with this approach, we are able to control it through the mobile phones. Can you compare your model with the existing methods in terms of cost, in terms of effectiveness?
Yes, sir. This cost compared to previous model is the low cost prototype model. It's not need to spend more money, and then you can control. You can increase the payloads also
I
based
was
on your
actually
requirement.
expecting exact amount or fund that will be required in terms of maybe money. Uh, if that comparison is available, then we are in a better position to find out whether this is actually really giving us some good outcomes or not.
Yeah, sure, sure, sure. Actually, we done the literature surveys also, but literature surveys are not included this PPT. So because they gave the 10 minutes time only, so that's why I tried to avoid some parts in my presentation. So I just focused particularly for the methodology and then the results only.
Okay, thank you. Wish you all the best.
Yeah, thank you, sir.
Yes, thank you, sir, for your presentation.
Thank you.
Next, I would call Reena Pal to present her study on a lightweight zero trust security framework for IoT systems using ECC authentication, trust scoring, and machine learning based attack detection.
Am I audible?
Yes, ma'am.
One second. I'm sharing my PPT, ma'am. Give me a second, please. So, good morning, everyone, and welcome to all of you, and thank you for being here today. So, my name is Reena, and I'm presenting here my research, a light-weighted zero trust security framework for IoT system using ECC authentication, trust scoring, and machine learning-based attack detection. So I will take you through the this outline of my PPT. Like I'll start with the introduction, then we'll go to the motivation, purpose statement, then we'll talk about the results and the future scope of my research. So let's start with the introduction. As we all know, the IoT is growing very rapidly in this world. Like we are, for an example, we are using IoT devices at our home, like Alexa, smartwatches, and we are using IoT devices for health monitoring and also in industrial sensors or everywhere IoT is there, like in traffic system in cities. These devices make our life more efficient and more connected. But all of these, whenever the come some easiest things come, there are major concerns also. So the major concern with the IoT devices is the security. So why? Because the most IoT devices are resource constrained. That means they have limited memory and limited battery power and the processing capability. So because of these limited limitations, they cannot have proper security algorithms to be applied on because of these limitations. So as a result, we will get the like a weak minimal security mechanism to the IoT devices. This make a very easy target to the cyber attackers to attack them. So clearly, we always require a smart security model. So there, that's where our concept come. That is zero trust architecture. So the idea behind the zero trust architecture is never trust any device automatically and always verify before granting any permission to the every access. Now let's talk about the background and the motivation of behind this research. So in the previous researches, the traditional security approach was the perimeter based. Meaning of the perimeter based security, if any device inside into the network, it will consider as a trusted device. But in the case of IoT devices, this approach will not work by because IoT uses the distributed environment. So every devices are connected from the different locations and they can have a different software to be installed on, and they are highly vulnerable to be attacked. So this is the need of lightweighted continuous verification system is required to IoT devices. So it motivates us to design a zero trust based security framework to the IoT devices. Then what is the problem here? So now I explain the problem statement. IoT devices have, as I already told you, they have a resource constraint, and there is no, and existing solutions have heavy and inefficient approach. So there is no integrated approach that combine all the security techniques. Like traditional model do not work well with the distributed environment. So there is a need to design a lightweighted zero trust framework that will be helpful for the distributed environments. Now let's come to the literature review. So in the literature review, I have studied those papers, and we have already used some cryptographic algorithms like RSA, ECC. They provide security, but they are quite heavy. Like they can increase the payload to the IoT devices. And the second thing I have used in this research, that is machine learning algorithms. Machine learning is using like we have already using the machine learning algorithm, but the problem with that is they are expensive, and the computational cost of those machine learning algorithm is becoming high. And the third mechanism we have used is trust weight model. Why we are using these three in our research? Because every in the traditional researches, these techniques are used on the separate basis. We have integrated all the cryptographic algorithm and the machine learning on and the machine learning algorithm in our research. So the main gap uh, is what that there is no unified framework that combined lightweighted cryptography and the machine learning, also the trust scoring. But trust scoring means the device can be accepted or rejected on the basis of their signaling. So the objective of this work is like to design again a zero trust architecture. And by using the ECC algorithm, because the payload size of ECC algorithm is much lighter than the RSA, so that's why I have used the ECC. And I am using the random forest detection technique for the attack detection. And to make this research to very dynamic, I am using the trust scoring method to achieve the high accuracy with the low computational cost. The tools and technology I have used in this research is ECC, which is used for lightweighted authentication. And second is random forest, which is a machine learning algorithm used for the introduction detection. Then dataset I have used is IoT ID20 dataset, which is contained many kind of attacks, that which is those some are benign and some are malicious. It also contained the Mirai botnet and the DDoS attacks. The fourth thing I have used is Trust Engine. It combines the authentication results and machine learning predictions that are based on time, which are the signals are coming into the system. Finally, we have used the Python-based simulation environment with the ML libraries and the cryptographic modules. Then what is the methodology of behind this? We have a two-phase methodology. First, all the signals will be captured will be validated at the ECC benchmarking, and then it will go to the phase two, that is zero trust design. And then if they are safe, then only they can enter into the system. And if we go deeply to the workflow of this environment, so you can see that we have four layers. First is authentication layer. In this step, ECC based cryptographic handshake is used. So it will verify the identity of the device, so that it can whether check it is malicious or benign. Then second step, the detection layer, it will use the random forest model here to train the data set and to check all the features like packet count and byte rate, all the protocol information they are going to check. It will help us to detect the malicious activities. The third step is to trust scoring layer. In this step will each device will update dynamically. So if device behave normally, the trust score will increase, and uh, if device is if system feels it is malicious, then trust score will decrease automatically. The fourth step is access control enforcement. If everything is goes well, then the access is granted. Otherwise, there will be a blockage over there. So this ensures the continuous security to the system. As a result, here you can see that we have a confusion matrix. This matrix, first paragraph, first figure, you can see that this shows how well the model will able to classify the attacks and the normal traffic. It includes true positives and the false positives, also the false negative. In our model, we have achieved very high accuracy. The number of false positive and the false negative are very low. This means the model is very reliable.
Sorry for
Now the
interruption, ma'am. Gentle reminder that you've crossed 9 minutes.
uh, okay, then this is the ROC curve, and then this is the behavior insights. This is our trust score analysis. Here you can see that detection accuracy rate is 99.8%. So, in the conclusion, I would say that this framework is integrated of ECC authentication, ML detection, and trust scoring. So, it provides scalable and practical solution to the IoT securities. We have some limitation, like we have used some limited parameter to by implementing this research. So, there is a future scope. We can improve it further. So that's it from my side. These are the references. If anyone have any query, please ask. I'm ready to answer.
Michael, sir, any questions?
Thank you very much for your successful presentations. Congratulations. I have just one question. There are three components of your included in your security architecture: ECC authentication, trust scoring, and machine learning. Can you please explain how these three interact together?
Pardon?
There are three components in your
Hmm, hmm,
security architecture. You have the
yes,
ECC authentication, trust
yes.
scoring, and machine
Hmm,
learning. Can you please explain how these three interact
hmm.
together?
See, I have used ECC because it is used it preferred the smaller key size to compare any to detect any malicious attacks, and it will decrease the payload size and the trust engine. How the trust engine is going to work? It will aggregate all the authentication outcomes and machine learning predictions so that temporal decay of the computed and dynamic trust score for each device reflecting its reliability over time.
All right, thank you.
Sandeep, sir, any questions for ma'am?
Yeah, I have a question. Like you mentioned that you are going to address certain attacks which are
Hmm.
possible in the scenario. You also mentioned that it is related to the intrusion detection. So my question is, how exactly you are calculating trust score of each individual device if the focus is on the intrusion detection?
Uh, I have included very few attacks in this my in my research, like Mirai and DIS and port scanning. So I have used only one data set. So in the case of trust score analysis, if my device will going to scan every signal in a seconds, and if it seems if it seems malicious, then it will uh, cut down the trust score as zero, and if it is positive, then it will raise the trust score as well. So that's why I'm going to make a matrix over the for the trust score.
See for example, if there is a device who is making attack in the
Yeah.
scenario, then
Hmm.
that device trust score should be drastically low. And those
Yes.
who are not part of any attacks, their score should be high. So this seems to be a binary system wherein either the devices are fully trusty or not at all trustworthy. So
That's why our I'm sorry to interrupt. That's why I'm we are making a kind of you can see that the table format, which is every attack will be scanned every time it will enter to the system. In the traditional approach, it was if some packet is loaded into the system, it will never checked again. But in our case, the packet every time the packet try to pass a gateway or a router, it will scan every time. So the trust score maintain every time the trust score will be maintained, and if there is a suspicious activity, it will immediately block that signal.
yeah, my point is like if we find that there are some devices which are making attacks, why not to block simply all these such devices?
Yes, this is only the approach. I like if it find out like a suspicious device, then we will block it, that packet.
Yeah, that seems to be a straightforward decision wherein a device is making an attack, simply block it for any further communications.
Like every time there's whenever the packet is being uploaded into the system, it is not like that only the once the packet will be uploaded into the system, it will try again and again. So in my trust scoring algo, it will check packet in every second. So there will be a chances that it will be a false positive result. There will be chances, but in the in the data I have used, which is IoT ID 20, there is a accuracy rate of 99.8% for the trust score matrix.
Okay, thank you. All the best.
Thank you.
Yes, thank you, ma'am.
Thank you.
Now, next, I would like to call Azad Mohammed Sheikh to present his study on self healing real time operating systems using reinforcement learning based recovery policies. Azad, sir?
Hello.
Yes, sir.
Hello. Good morning. Give me a minute. Let me share the screen. Screen. Okay. Give me a minute. I'm just having some trouble with presenting it, sharing the screen. Give me a minute, please. And presentation. Yeah. Please bear with me. I just got. Oh, wait. Sorry about the delay. Is the screen visible?
Yes, it is visible.
Thank you. Good morning, everyone. I'm Azad Mohammed Sheikh. I'm a platform design engineer from Stellantis. And in this presentation, I'll discuss self-healing real-time operating system using reinforcement learning-based recovery policies. In automotive and other safety critical embedded systems, faults such as memory leaks, overload, starvation, or priority problems cannot simply be detected and logged. The system must recover quickly enough to protect timing behavior and system stability. In this presentation, I'll show you how I modeled the runtime recovery as a learning problem, implemented the idea on a free RTOS based platform, and evaluated whether a compact queue learning policy can deliver fast and reliable recovery with very low overhead. I'll begin with the background and the problem we are trying to solve. Then I'll state the objective and focus on the proposed reinforcement learning framework, the experimental setup, and the main results. Modern automotive platforms depend heavily on autos behavior being predictable because functions such as control, sensing, communication, and diagnostics all run under strict timing constraints. The challenge is that the real-time systems still experience runtime faults, even when the scheduler is well designed. Issues such as memory leaks, queue buildup, task starvation, stuck sensors, and or sporadic overload can disturb normal execution. Most prior work is strong at anomaly detection, meaning it can say that something has gone wrong, but detection alone is not enough. What matters is practice is whether the system can choose an effective recovery action quickly and continue operating safely. Let's look at the problem statement. Traditional recovery is usually rule based, which means engineers define a fixed reaction for each known fault. That works for simple cases, but becomes rigid when the system faces mixed conditions or operating states that were not fully anticipated during design. In a real-time system, we also do not have the luxury of long decision making. Recovery has to be quick, lightweight, and suitable for deployment on constrained embedded systems. Can an RTOS recover automatically at runtime? Can a learned policy choose better actions than static or random recovery? And can all of that be done without introducing unacceptable overhead? That is the motivation for this work. These are the objectives of the research. Design a self-healing RTOS architecture built around the RL-based recovery agent. Define the learning problem in a practical way by specifying the state space, the action space, and the reward function so that the policy would care not only about fault resolution, but also about timing and system impact. Train and validate the policy under multiple RTOS fault types in free RTOS environment. Compare the learned policy against baseline approaches to see whether it actually offers a meaningful advantage in terms of recovery, success, response time, and deployability. Literature survey can be grouped into three broad areas. The first area is anomaly detection in dependable and real-time system. That body of work is useful because it helps identifying faults early, but it usually stops at detection and does not tell us which recovery action should be chosen. The second area is self-healing and autonomic computing. These studies provide architectural ideas, but most of them are general purpose frameworks and do not give validated evidence for compact RTOS recovery policies. The third area is reinforcement learning for system management. RL has been used successfully in resource allocation and adaptation problems, but not much work has shown autonomous learned fault recovery inside an RTOS. That is the gap this paper addresses, a small explainable RL policy with implementation and measured results in real-time operating environment. The experiments were implemented on free RTOS version 10.4 using POSIX port on Linux with a workload of 12 simulated tasks spanning periods from 10 to 1000 milliseconds. During execution, 6 fault types were injected: sensor degradation, stuck sensor, priority inversion, memory leak, sporadic overload, and task starvation. The recovery agent was based on queue learning. It observed an 8-dimensional state made up of health and workload indicators such as anomaly type, CPU utilization, memory availability, queue depth, affected priority, system load, time since the last fault, and previous recovery outcome. Based on that state, it selected one of the 6 actions, including restart, priority adjustment, suspension of low priority work tasks, graceful degradation, or doing nothing when intervention was unnecessary. Training was performed over 5,000 episodes with a epsilon greedy exploration strategy. It's a method used in reinforcement learning to balance the exploration, trying new actions, and exploitation, choosing the best action already known. The key result is that learned policy achieved 4,900 successful recoveries out of 5,000 episodes, which is 99.2% success with zero system crashes. The average recovery time was only 0.06 millisecond, and the computational cost of the RL agent itself was about 0.27 microseconds per recovery, which is effectively negligible for a real-time use. Objective 2 and 3, when we break performance down by fault type, the success rate remains consistently high across all 6 classes, ranging from 98% for stuck sensor cases to 99.9% for sporadic overload. The action distribution is also informative. Across 5,000 episodes, the agent executed 7,200 recovery actions in total. The most frequent choices were graceful degradation at 24%, suspend low priority at 22.2%, restart task at 21.9%, and boost priority at 20.8%. In other words, the policy learned a balanced strategy instead of overusing one action everywhere. An important behavioral insight is that agent often protects system timing first. It tends to prefer graceful degradation or selective suspension when the system is under stress, which is sensible pattern for automotive real-time operations. Here I compare the proposed method with 3 baselines. With no recovery, success is effectively 0 because the system remains exposed once a fault occurs. Random recovery is slightly better, but only at about 16.7%, which is what we would expect when actions are chosen without state awareness. The static rule-based method is fast, but its success is only around 45 to 55% because it cannot adapt to the full runtime context. The key point is that speed alone is not enough if the selected action is often wrong. RL-based policy gives the best overall balance. It preserves response speed that is still suitable for real-time operations while increasing recovery success to 9.2%. To conclude, this work shows that self-healing in RTOS can be made practical when the learning model is compact and formulation is aligned with real-time constraints. The main evidence is strong, 99.2% success rates recovery over 5,000 episodes. Together, these results suggest that the approach is not just academically interesting, but potentially deployable. At the same time, I want to be clear about the scope. This study is based on simulation with free autos for 6 environment. The natural next step is hardware evaluation, running it on a ECU, followed by concurrent fault scenarios and broader automotive fault coverage. These are the list of references I used, which supported the problem framing, the design of learning agent, and the broader self-healing system perspectives. Questions?
Michael, sir, any questions for him?
Yeah, thank you very much. Congratulations once again on your successful presentation. I have just one question for you. The real-time operating system you made use of, can you enumerate the key characteristics that you leverage on for the real-time operating system? What are the key characteristics of the real-time operating system that you made use of in your work?
The key characteristics of real-time operating system is the timeliness, the determinism of the task, right? If a task should take 20 millisecond, it should take 20 millisecond. If a task should take 200 millisecond, it should take 200 millisecond. When I say determinist, real time doesn't really mean fast. It means deterministic. So the most important part of this real time is like the concept of real time operating system is very clear. Any highest priority task should run at any time. So your system has to be designed around this basic concept, and we can meet that determinism.
All right, thank you very much.
Thank you.
Sandeep, sir, any questions?
Yeah, I have a question. I want to know, like, are there any limitations of the proposed method?
Yeah, limitation is, as I said, this is the state space, the action space are very much constrained. And this was just chosen like 6 recovery faults, and those were like very much limited for that experiment. And it can be more in a real time ECUs or any hardware. Those faults are may not be that enough, but still all the faults can be grouped under these 6 faults. That's why I chose these 6 faults. And other limitation is when you do it on a hardware, the actual timing may differ. It may not be so deterministic like this. It may differ based on the memory, based on the memory access, caches, and the sensor delays. So those are the few things which we need to take care when I will consider that as the limitation.
Okay, thank you.
Thank you, sir. Thank you.
Yes, thank you, sir. Now, next, I would call Yuki Aryo to present his study on a SIFT-based classification method for traditional Japanese stencil images.
Okay. Can you see my screen?
Yes, sir.
Okay. Title: A shift-based classification method for traditional Japanese stencil images. My name is Ari Yuki from Kyushu Institute of Technology, and I will be presenting this research. First, I will explain the research background. Issei katagami are traditional Japanese paper stencils used for dyeing kimonos and Japanese paper. They are composed of zu, which is the target part to be recognized, and ji, which is processed as the background. The primary patterns, like those enclosed in the red squares, are zu, and the repeating structure, like those enclosed in the blue square, are ji. The pattern of Issei katagami are extremely complex, making analysis and digital processing difficult. And therefore, although about 80,000 existing stencils have been digitized, the classification is not progressing. Automatic classification of Z and G is particularly challenging, and this process is currently performed manually. However, manual processing all images take an enormous amount of time. Therefore, as a first step to reduce the workload, we aim to classify them into G-only images and Z and G images. Using this classification of G-only images and G images as a first step, we will connect it to the precise classification of Z and G. Furthermore, through this process, we ultimately aim to construct a fully classified database in the future. Here, G-only images consist of a single repeating structure. On the other hand, Z and G images have a different structure mixed in on top of the repeating structure. In this research, we classify them using this repeating structure. From here, I will explain the shift feature used in this research for classification. Shift is an algorithm for extracting and describing key points in an image, and the process consists mainly of 2 steps. First, points that become local maxima and minima are detected as key point using difference images in scale space. Next, the image gradients around each key points are analyzed and described as a 128-dimensional feature vector. With these shift features, we classify Issei katagami while determining their repeating structure. First is the feature vector. This graph shows some of the feature vector for the only images and the images. It can be confirmed that the feature vectors of the only images have similarity, while those of the images do not. By utilizing this similarity of feature vectors, we can determine the repeating structure from shift features. Next is the scale. The scale corresponds to the size of the image pattern captured by the key point. In gene-only images with repeating structure, the scales of key points are thought to concentrate on specific value, appearing as a characteristic in the distribution. Looking at the output scale distribution, we can confirm area where values are concentrated like mountains. To, to quantify this characteristic scale distribution, we use kurtosis in this research. We calculated the scale kurtosis for 50 G-only images and 50 Z&G images respectively, and compared the distribution and range of their values. Blue represents G-only images, and orange represents Z&G images, and we could confirm a clear difference in the center of the range. From here, I will explain the proposed method. In this method, classification is performed based on the following step. First, regarding the cosine distance of the future vectors, our method applies the transportation problem to determine repeating structures. Specifically, we consider a transportation problem from a randomly sampled set of key points to the original set of all key points. Furthermore, to determine the abundance of repeating structures, we set a constraint on this transportation problem. We prohibit movement to itself and set a condition that destination of each key point must not overlap with that of other key points. Based on this, we calculate the cosine distance of the future vectors as a transportation cost. This cosine distance represents the similarity between future vectors and takes a range from 0 to 1. It takes small values for gene-only images with repeating structures and large values for Z-ROG images. Next, since scale kurtosis represents the characteristic of the image distribution, it is calculated for each image. Because low kurtosis values have a wide range and are not suitable for comparison, logarithmic transformation is performed to suppress the range. Also, it weights normalized to value between 0 and 1 to match the range of the cosine distance mentioned earlier. Using these two, the transportation cost of cosine distance and the scale kurtosis, we define an evaluation function that determines the evaluation value for classification. To improve classification accuracy, logarithmic and path transformations are applied so that the difference in evaluation values between G-only images and G images become larger. We determined the evaluation function based on the following formula, which was able to widen the difference the most among multiple forms. Based on this evaluation function, we set the threshold as a classification criterion. First, we split 100 images for which evaluation values were obtained into 50 training data and 50 test data. Next, we set the threshold based on the training data and measure the accuracy with the test data. We performed this trial 10 times. Data splitting is performed randomly for each trial, and a different dataset is used each time. From here, I will explain the experimental result. First, the result of the evaluation values. Based on the defined evaluation function, we calculated the evaluation values for G-only images and Z-and-G images. This is an example of those evaluation values. When we compare the distribution of 50 images each, there is a clear difference in evaluation values between the blue G-only images and orange Z-and-G images. From these results, it can be confirmed that G-only images have small evaluation values and Z-and-G images have large evaluation values. When we performed classification using these evaluation values, the threshold was the best accuracy was this one. Calculating the accuracy, precision, recall, and F measure at this threshold results in the table shown. Achieving an accuracy of 98%, allowing for highly accurate classification. Next, we will identify and discuss the misclassified images. First, regarding this image, misclassified as the RG image. The counters of its repeating structure are more complex compared to other G-only images. Next, looking at the image misclassified as G-only images, you can see that the included is small relative to the entire image. We believe these factors cause the misclassification. In conclusion, a method achieved 98% accuracy, as shown here. Moving forward, we aim to improve the classification of smaller figures to further enhance performance. This concludes my presentation. Thank you for your attention.
Michael, sir, any questions?
Yeah, thank you very much. Congratulations on your successful presentation. My question is just only one. Why do you have to focus only on traditional Japanese stencil images? Then, can your shift-based classification be applied to other stencil images in other parts of the world? That's my question.
Could you repeat your question?
Hello?
Could you repeat the
Okay, the question.
Okay,
okay, I said, why did you focus only on Japanese stencil images? And then this, your shift-based classification, can it be applied to other stencil images in other parts of the world? Why Japanese market only?
Ise Katagami, Japanese translate paper is have ownership and copyright. So this is difficult classification. For example, crowdsourcing, because redistribution is difficult. So database is not perfect. So we because we aim into is a katagami.
Are you done?
Yeah.
Well, your explanation is not very clear, but my simple advice is, instead of limiting yourself to Japanese market, yes, you can try Japanese, start with addressing Japanese stencil images. But coming up to a larger audience like this, you should be talking of sieve methods that can be adapted to larger audience, so that when you are to sell that technology, they're not just limited within Japan. It can be sellable in other parts of the world. Thank you very much. Once again, congratulations.
Yes, thank you.
Sandeep, sir, any questions for him?
Yeah, I have one question. So why don't you apply standard classification machine learning or deep learning approaches for this problem?
Japanese stencil ise katagami is small difference pixel size. So deep learning is not suitable to classify this katagami. So
Have
we
you,
use shift.
my
features.
question is, have you tried it and you got that the results are not so good? Have you done that?
What could you repeat your question?
Have you tried applying different machine learning classification algorithms and found that the results are not good?
Yeah. So sorry, we have to investigate this. So we aim to this problem.
Okay, thank you. Wish you all the best.
Okay, thank you.
Thank you very much. Now, next, I would call Sakti Saranya to present a study on comparative overview of deep learning architectures for disease detection in medicinal plants. Sakti, ma'am?
Yes, ma'am. May I audible, ma'am?
Yes, ma'am.
Shall I present, ma'am?
Yes, ma'am.
Good morning to everyone. I am Sakti Saranya, PhD Research Scholar from the Department of Information Technology, Bharathiar University, Coimbatore, India. Now I am going to present my topic, Comparative Analysis of Deep Learning Architecture for Disease Detection in Medicinal Plant. These are the content which the presentation covers: introduction, problem definition, literature survey, comparative study, methodology, result and discussion, challenges, conclusion and future enhancement, references. Since the medicinal plants like tulasi, aloe vera, mint, ashwagandha, these were used to prepare in traditional medicines. So the diseases of these medicinal plants will affect their yield, and it will also reduce the quality as well as the medicinal value. By identifying the diseases manually, it will require the expert knowledge, and also it will take more time to diagnose the diseases. So that the deep learning models provide the automated approach to care for this disease detection in medicinal plants. This is a problem definition. By detecting the diseases in medicinal plants is so difficult because the symptoms are very small and sometimes it not visible at the early stages. In rural areas, there are lack of experts to diagnose the disease in medicinal plants. The existing works mainly focus on the agriculture crop, like food crops only, not in medicinal plants. So that this work decided to propose a machine learning, deep learning models to detect the diseases in medicinal plant. These are the literature review. Gupta et al. Have been implemented the deep learning models in order to improve the accuracy, and Ujjain et al. Have been proposed the augmentation techniques in order to handle the variations in background and lighting conditions. Mohanty et al. Have been proposed the deeper architecture like DenseNet and ResNet architecture. Since we need an improvement in detecting diseases in medicinal plant, this is a comparative study of this work. I have been compared the various deep learning models like ResNet, DenseNet, and EfficientNet. EfficientNet can be used to improve the performance of these new features, and DenseNet also used to improve the feature reuse. So that based on this comparison, this work proposes the proposed model like a hybrid EfficientNet as well as DenseNet. This is a methodology. This is the workflow of this proposed work. In this proposed algorithm, first the raw image data of the plant leaf image can be taken as an input, and then after that the data augmentation technique can be applied. After that, the data is training. The data can be split into training as well as testing. After that, the deep learning models, the proposed model like EfficientNet and DenseNet model has been used to classify the data. After that, evaluation metrics can be used to improve the model performance. Finally, the model will predict whether the leaf is diseased or healthy. This is a result and discussion. In this work, I have been used 3,250 images, 220 images. Among that, 2,250 data were used for training and 970 images were used for testing. The performance of this proposed work have been evaluated by using the confusion matrix. This table shows the performance metrics of this proposed work. The proposed work achieved the high accuracy by comparing to the existing models, which achieved the accuracy as 98.1, precision as 97.8, recall as 98.4. This is a graphical representation of this performance evaluation matrix. The challenges faced of this work is there is a limited availability of data set in medicinal plants. The another thing is feature extraction to handle. In order to handle the data, in various background and lightning conditions, and then also need for more optimization for real-time deployment. Then conclusion and future enhancement. This study proposes the hybrid model like efficient net and dense net model, which shows the high accuracy by comparing to the existing work. This model achieved the accuracy as 98.4, so that this model effectively detects the diseases in medicinal plant with high reliability. In future work, this model can be deployed into the mobile application and IoT devices in order to, and also incorporated with the explainable AI technique in order to explain the diseases well to the farmers. These are the references which I take for this work. Thank you.
Michael, sir, any questions?
Yeah, thank you very much. Congratulations on your successful presentation. My question is, which of the deep learning architectures did you adopt in this study and why? Which architecture
Sir,
and why? Which
in this
deep
study,
learning architecture, yes, and why?
in this study, I have implemented the hybrid model like efficient net model and dense net model, efficient net as well as the dense net model to use to classify the data.
Yes, the second question is why? Why that architecture? Why?
Because the efficient net model can improve the performance of the new with fewer parameters, and the dense net also used to improve the feature reuse. By combining both two, we can achieve the high accuracy.
Thank you very much.
Thank you, sir.
Sandeep, sir, any questions?
Yeah, I have a question, madam. You mentioned that you use a data set.
Yes,
And
sir.
may I know the source of that data set? And
Sir,
another question is like whether this data set is related with the medicinal plants, because your work is focusing on the medicinal plant study.
yes, sir. Sir, I have been used this work for the benchmark dataset only. Now the work is ongoing for my PhD work. I have been customized the dataset for this medicinal plant, sir.
The existing data set is not related with the medicinal plants. That's what you want to say?
Yes, sir. Sir, some of them having the dataset as a medicinal plant. Some of them are not in the medicinal plant, sir. Dataset.
So my question would be like how you would like to relate the results that are achieved from this work, and whether they will be really applicable for the medicinal plants.
Because the diseases are more look similar, sir. Most of the diseases are look similar for the plants. That's why I am choosing the dataset.
But in that case, do we need a separate method for medicinal plants specifically? If the results are similar, the pattern is similar.
Yes, sir. Yes, sir. I selected to implement, sir, but I cannot achieve the high accuracy in the real-time data set, sir, because there is need for more data augmentation technique and pre-processing. The raw data can be pre-processed as well as the augmentation technique can be applied in raw data, sir.
Okay, thank you. All the best.
Thank you, sir.
Yes, thank you, ma'am. Now, next, I would call Kari Sai Vardhan to present their study on evaluating explanation consistency of explainable machine learning models for heart disease risk prediction. Kari Sai Vardhan, sir. I repeat, Kari Sai Vardhan or any of the co-authors of this paper. All right, Dhruv Bhattawar. Dhruv Bhattawar, are you present, sir? Or any of the co-authors of Hybrid AI Framework for Smart Energy Grids, DRL-based control with solar fall detection. Maklis Al-Mubarak.
Okay, I'm here.
Yes, sir. Please present your study on the EPIC E framework, a multidimensional model for evaluating the effectiveness of dynamic infographics in digital news visualization.
Okay, I will share my presentation. Okay, good morning, everyone. My name is Muhulis Al Mubarak. Today, I will present my paper, my research, the EPIC framework, a multidimensional model for evaluating the effectiveness of dynamic infographics in digital news visualization. Let me begin from abstract. In brief, this study addressed a critical gap in how we evaluate dynamic infographics in digital news delivery. Traditional evaluation models, specifically the EPIC model, were built for passive advertising audience and lack the engagement metrics needed for today's social media platform. So we proposed the EPIC E model, extending EPIC by adding an engagement dimension. We collected data from 572 followers of Batam Post, a leading Instagram-based news platform in Batam, Indonesia. Okay, introduction. Why visual content matters in digital news landscape. In today's rapidly evolving digital journalism landscape, news consumption has fundamentally changed. The proliferation of mobile devices and social media platforms means audience now expect content that is not just accurate but also visually engaging. Infographics have emerged as a key communication tool in digital journalism, and among them, dynamic infographics, which combine motion, audio, animation, and progressive storytelling, significantly outperform static format in terms of attention capture, information retention, and audience engagement. As you can see on the slide, the difference between static and dynamic infographic is substantial, from fixed visual format to multi-layered storytelling optimized for mobile screen. Okay, research problem. The measurement gap in evaluating social media-based news content. Despite the growing use of dynamic infographics in digital news, there is no comprehensive framework to systematically evaluate their effectiveness on social media. The traditional EPIC model, developed by A.C. Nielsen 1997, covers four dimensions: empathy, perception, impact, and communication. While useful, it was designed for passive audience in conventional advertising context. On platforms like Instagram, audience engagement through like, share, comment, and viewing duration drive algorithms visibility. The EPIC model simply does not capture this. This is the core problem we address by proposing the EPIC E model, adding an engagement dimension as the fifth component. Okay, this is comparison between study in related works. We can see in the first group, you can see Putra and Lisdayanti used EPIC to evaluate electronic advertising via web series, and then Sadewa applied EPIC to Instagram ads, and Rosikin and Masud used EPIC in digital marketing strategy for manufacturing, and Agustin examined EPIC for social media promotion in e-commerce. And second group, Jamaluddin EPIC for coffee advertising, and the research we can see the all before study the risk gap is now clear. None apply the EPIC model to dynamic infographic in digital news visualization on social media. Furthermore, all X study used to traditional four-dimension EPIC without any engagement metric, which is essential for interactive platform. This gap directly motivate our development of the EPIC model. Okay, the purpose EPIC E model. The EPIC model extends the conventional EPIC framework by adding an engagement dimension as a fifth component. As shown on this slide, the five dimensions are EPIC, empathy, persuasion, impact, communication, and engagement, measuring Instagram interaction rate, viewer attention, and motivation to watch more content. The model incorporates 6 multimedia elements. Okay, we can see the illustration. To establish our research gap, we review a prior study that apply EPIC model. Okay. This figure illustrates the complete EPIC model structure, showing how the 6 multimedia elements map to the 5 EPIC dimension and how the measurement instrument and scoring scale are organized. So EPIC model, they will measurement empathy, measure overall aesthetic experience, persuasion, measures message effectiveness, impact, multimedia information retention, communication, clarity of multimedia presence, and engagement, measurement, Instagram interaction, like, share, comment, viewer attention, and participation. Okay, this is the process of methodology. ORIS followed a four-phase approach. Phase 1, literature review, identify gaps in existing EPIC framework. Phase 2, model development, develop a EPIC with 16 measurement indicator, then conduct a three-stage expert validation. Validation the evaluation form, model structure, and user questionnaire. Phase 3, implementation, design, and publish denim infographics, news content on Instagram, Batam Post, news company. So phase 4, evaluation, collect and analyze data. So this is the respondent of demographic. We collected 572 valid response, exceeding the minimum of 384 required by Cronhan's formula at 95% confidence level. The 70 to 35 confirm our sample represents active digital news consumer and regular Instagram user. And for validity, we use person product moment correlation. All 16 measurement items were valid with R values ranging from 0.258 to 0.497, substantially exceeding the critical threshold of 0.082. For reliability, Cronbach alpha was 0.6612, classified as acceptably for exploratory social science research, as confirmed by Raharjani et al. 22. Okay, this is the EPIC effectiveness evaluation overall result. Descriptive analysis of mean score across all 5 EPIC dimensions. We can see the engagement get a higher score at 4.33, and impact and empathy both score 4.29, and communication score 4.19, and persuasion score 4.15. Okay, this is dimension analysis score by individual indicator. We can see empathy versus an impact for the first. For empathy, we can see the indicator dimension average 4.29, and in persuasion dimension average 4.115, and impact dimension average 4.29. And the last, engagement and communication. Engagement, the key finding, the engagement dimension achieved the highest mean score among all 5 EPIC dimensions. The indicator interest in viewing more related content is the single highest score item across the entire instrument, confirming readers' strong motivation to interact with dynamic engagement dimension capture a genuinely distinct and important construct. Okay, the conclusion and contribution. And summary conclusion, this research successfully proposed and validated the EPIC-E model as a comprehensive framework for evaluating the effectiveness of dynamic infographic in digital news visualization by incorporating engagement as an additional dimension to the traditional EPIC model. Okay, and then the research objective achieved three objective. Design EPIC-E model successfully, proposed and validated by domain expert, implement dynamic infographic, create with 6 multimedia element and publish on Instagram, Batam Post, evaluate by effectiveness measurement measure across 5 EPIC-E dimension with 572 respondents. And okay, this is the limitation and future research. Research limitation, single organization just focus on Batam Post limit generalization and platform specific. In the study, we focus on Batam Post, on Instagram. And then future research direction, we recommended to cross-platform study, multi-organization study, longitudinal study, and AI power integration. Okay, and integrate EPIC score to intelligent content enabling automated assessment, real-time analytic dashboard, and adaptive visualization system. Example, EPIC score could be visualized through real-time analytic dashboard that monitor audience engagement, communication clarity, and impact metrics, enabling editor to iteratively refine infographic design based on live user interaction data. Overall, The EPIC model offers a practical framework for evaluating the visual communication effectiveness in digital journalism with potential for broader application across platform and cultural contexts. Okay, this is the fully reference. Thank you.
Michael, sir, any questions?
Yes, just one question. Congratulations on your successful presentation. My question is one, what are the key dimensions of the framework and how are these dimensions selected or derived?
Okay, the key dimension is engagement. So for the measurement, interaction rate, like share comment, and then how, sorry, the second question.
How are these dimensions selected or derived? How are these selected?
Okay, they're selected by expert model. So because before study, I see they not use engagement for social media, just EPIC model, empathy, person, impact, communication. So if we wanted to measurement in social media, we must use engagement because it's not using before study. So I put it on the new model.
Right, thank you very much.
Okay, thank you, sir.
Sandeep, sir, any questions?
Yeah, no question from my side. Thank you.
Okay, thank you, sir.
All right, thank you, sir. Next, I would call Maricela Pinargote Ortega to present her study on usability and accessibility on the website of the Inclusion, Social Equity and Gender Unit of the Technical University of Manabí. Maricela, ma'am? Or any of the co-authors? All right, Sona Ravindran.
Hello, yes, ma'am. Good morning, ma'am.
Yes, good morning, ma'am. Please present your study on Wave Trust, trust-based reinforced routing protocol against malicious node influence in underwater sensor environments.
Okay, let me share my. Is it okay, ma'am?
Yes, ma'am.
Is it visible? Okay. Good morning, all. I'm Sona Ravindran. I'm a research scholar at CMAX, Chennai, India. I'm here to present a wave trust scenario for underwater wireless sensor networks. So, as to underwater wireless sensor networks, as it is called UWSCs, they play an important role in applications such as environmental monitoring, resource exploration, military surveillance, and disaster prevention, etc. However, we know the underwater conditions, the harsh underwater environment. These networks face many challenges. The main challenges are identified such as high propagation delay, limited bandwidth, node mobility, and many energy-related issues are there. In addition to this, there are security threats as well. So to address this, I'm proposing this wave trust, a lightweight and behavior trust model. To discuss the works I reviewed, there are many approaches such as agent-based routing are there, then machine learning techniques, fuzzy logic, and Q-learning. All these have been proposed to improve the security in underwater wireless sensor networks. Additionally, there are intrusion detection methods and multipath routing. These also have been explored. However, these approaches suffer from limitations such as high computational overhead. Many of them have this computational overhead and poor adaptability to dynamic situations in the underwater environment. So, a requirement for a lightweight adaptive model is necessary for the communication and UWS sense. The proposed methodology, that is the wave trust, it addresses this method addresses the challenges with trust evaluation and with Q learning. So the objective of this method is to detect malicious nodes as well in the real time while enabling secure and energy efficient routing. So the trust value in this methodology, we are computing the trust value in direct method and indirect method, and we are combining the values together. And Q-learning is used to learn optimal routing paths using rewards based on trust, energy, and latency. So thus with this method, we can improve packet delivery and reduce energy consumption and make the system robust against dynamic attacks. So here I give you the the architecture of my system. First, basically, the system it consists of underwater sensor nodes. These nodes collect data and transmit it to a sync node through multi-hook communication. So from the underwater sensors, a sync node is accepting the data. At each step, the node behavior is evaluated using trust parameters. These trust parameters are the basic key parameters on any communication nodes. So based on this evaluation, harmful nodes are identified and avoided in real time. Oh, after that, the Q-learning is processed and the better path is identified, and the communication is data transmission is performed through the identified trusted path. Then afterwards, the trust values of trust and Q values are updated. And again, we are accepting feedback from the SIG node also, so that this feedback can further refine trust and routing decisions for further communication. So this is the architecture. And the trust parameters, we need to calculate the trust values. For this, we are using trust parameters. There are four trust parameters we are using, four key parameters for any node behavior. That is, first one is the packet forward ratio, PFR. This measures how reliable is a node's packet forwarding feature is. Then the second parameter we are using is energy behavior consistency, EBC, that determines whether the energy usage of a node is the expected usage or not. Then third, latency observance, that measures the delay, if the delay is acceptable delay threshold or not. Then the fourth parameter is link quality indicator. That is again reliability of communication, measures the reliability of communication between the nodes. This after we are uh, collecting all these parameters, we are calculating these parameters. The ranges of values will be, for each parameter will be 0 to 1. The values near to 1 indicates more trust. So the values which are given to nearest to 1 nodes are selected for communication. Which are below the threshold, we are avoiding the nodes are malicious nodes. Then the direct trust computation is done using calculator, as it is calculator's weighted combination of the four before said parameters. That is, these weights are assigned to these parameters on real time. That is, the weights are assigned in real time in real situations. So the weights W1, W2, W3, W4 for each parameters are assigned, and the combination of values obtained as the result for direct trust result. So the highest trust value is identified as the reliable node, and which is preferred during the routing. The indirect trust, we are calculating the indirect trust also. The indirect trust is obtained based on the recommendation of neighboring nodes. So this indirect trust is also we are combining with the direct trust, and thus we are identifying if a node is reliable or not. So this helps in identifying the malicious nodes or harmful nodes in the course of communication, and we can remove these nodes very early stages. And this provides adaptive and secure communication and a trust-based routing decisions are made in the real time also. The algorithm, I have 3 slides in the algorithm. So algorithm works in 6 steps. First, we are inputting the values, nodes and weights W and W4, W to W4 for the parameters importance. Then the expected values, energy and delay, etc. And in the step 1, we are calculating we are monitors the node behavior. In the real time, this is the first monitoring done. The behavior of each node is observed here, and when we collect data like packets and forwarded, then acknowledgements, delays, energy usage of a node, everything on real time. As second step, we are computing the trust parameters, that is the packet forwarding ratio, EBC, latency, and reliability are calculated in the second step. And all values are supposed to be between 0 and 1. And as I said earlier, values nearest to 1 are more reliable. Then in the third step, we are calculating the direct trust using the equation, that is the weighted sum of this packet forward ratio and the energy balance and delay and reliability link quality. And in fourth step, the indirect trust is calculated. This is, as I said earlier, this is the recommendation for node J from the neighboring nodes. This is given, say if there's a node I, and if it wants to identify the trust of node J, it can ask node K. Say if there's a node K, from the node K's impression, the node I will identify K's trust. And in the fifth step, this is the final trust seen. So the final trust is the combination of direct trust and indirect trust value. And finally, in the sixth step, we are updating the trust table. All the trust values are stored and they are updated and used for later routing decisions and avoiding malicious nodes, etc. So that is a briefing of my algorithm. Now, discussing the results, I compared this method with model with TAODV and fuzzy trust methods. On the metrics, packet delivery ratio and false positive range, detection accuracy, trust convergence time, then throughput, routing overhead, energy consumption, etc. And I've come to a conclusion that wave trust outperforms these two methods. So it's given in the values. There are a fair difference among these values and for the wave trust. So wave trust provides higher delivery and throughput in lower energy consumption, and there is a better detection of nodes also. So this lower energy again is an important factor in the underwater wireless sensor networks field. So this is my identification of the work wave trust compared to other two methods that is used. And this is the comparison chart for the
Excuse me, ma'am.
method.
Gentle reminder that you've crossed 9 minutes. I request you to conclude in the next minute.
Okay. And in conclusion, wave trust provides a lightweight and effective trust evaluation model for UWSNs, and it improves security, enhances packet delivery, and reduces energy consumption through adaptive routing. As a future work, I think this model can be extended for real-world underwater deployments and more complex attack scenarios. Thank you. These are my references. Thank you.
Michael, sir, any questions?
Yeah, thank you very much. Congratulations on your successful presentation. Just one question.
Thank you, sir. Okay, sir.
How is trust established and updated among nodes in your system?
The trust is established by using these key parameters. I use the 4 key parameters because they are the most important parameters in the nodes communication. how effectively it can forward a packet and how much delay it takes and etc. So that's
How
the
is
ethic.
how is it now updated? How is that trust updated?
Because the trust is how well a node can send the data that is from the underwater environment. These nodes are mobile nodes as well. So, if the node has the energy level below a threshold, the node cannot be selected. If a node has a below energy level, it cannot perform as we are expecting, and the latency, everything will be depleted. So, the four parameters are I've considered in my work.
Okay, thank you very much. However, you need to address the last question: how trust can be updated, just for improving
Sir?
on your work. Thank you very much. I said you will need to work on updating trust, not for now.
Okay.
Yes, to improve your work. Please
Okay.
find out how trust can be updated. Thank you very much.
Okay, sir. Okay, sure. Sir.
Sandeep sir, any questions? All right, thank you so much, ma'am.
Thank you. Thank you. Good day.
Now, this is the last call for Kari Sai Vardhan. I repeat, Kari Sai Vardhan or any of the co-authors of this paper. Dhruv Bhattavar.
Yes, I am there.
Yes, sir. Please present your study on hybrid AI framework for smart energy grids, DRL-based control with solar fault detection.
I, so is my screen visible to you?
Yes, sir.
Okay. So good morning, everyone. I am Dhruv Bhattavar, and today I will be presenting our work on hybrid AI framework for smart energy grids using DRL-based control with solar fault detection. This work focuses on improving how solar panels are monitored and controlled using AI. So let's begin with the problem. Currently, managing solar panels and energy grids is quite complex and mostly manual. The issue is that the faulty or overrated panels often go unnoticed. This leads to energy loss and sometimes even safety risks. Existing systems use fixed rules, do not adapt to real-time conditions and require manual intervention. So even if we have monitoring dashboards, they only show data. They don't take actions. So the core problem is we don't have a system that can both detect and automatically respond to them in real time. To solve this, we proposed a hybrid AI framework. The system combines deep learning for detecting faults, reinforcement learning for making decisions. We use thermal images of solar panels, CNN models to detect hotspot, then a DRL agent decide which panel should be on or off. We also provide a dashboard where users can see monitor panel status, view alerts, and even manually control the system. So overall, the system is intelligent, automated, and adaptive. So the objective of our project is to make solar grids smart and self-managing, to detect faulty panels early using AI, to automatically handle faults without human intervention, or to optimize energy usage and reduce cost, and to ensure smooth operation even during the failures, and to provide real-time updates. In simple words, automation plus safety plus efficiency. So the motivation comes from the real world challenge. Hotspot occur due to shading defects or electrical issues. This hotspots reduce efficiency by 10% to 30%, damage panels, and can even cause safety hazards. Manual inspection is slow, expensive, and not scalable for large solar farms. So we need a system that works in the real time and prevents problem before they become a serious. So this was a research gap. First, fall detection and the control are separate, so decisions are made without the considering the faults. And the second, the DRL system are fault agnostic. They don't know which panel are dangerous. So am I audible? Like, second, DRL system are fault agnostic. They don't know which panels are dangerous. System use profit soft penalties that discourage wrong actions but don't prevent them. Fourth, no proactive thermal management. They act only after overheating happens. Fifth, no dual safety mechanism. Our system solves all these issues by integrating everything into a small intelligent pipeline. So the innovation that we are doing in a project is closed loop architecture detection directly influences decision, and then faulty panels are completely blocked. Agent no panel health before acting, then AI prediction plus installed rule based protection. Cause of this, we achieve high efficiency and zero fault at same time. So this is a research gap. Where in our literature survey we analyzed existing work in solar fault detection and energy optimization. We found that deep learning models like UNIT are highly effective for detecting the fault, such as hotspot from thermal images, achieving high accuracy in segmentation tasks. On other hand, reinforcement learning approaches like PPO are widely used for optimizing energy management in smart grids due to their ability to handle dynamic and uncertain environments. However, the key limitation across existing work is that these two components are treated independently. Fault detection system only identify the issue but do not influence the control. Additionally, most systems rely on the soft penalties for unsafe actions which do not guarantee safety. Therefore, there is a clear research gap in integrating perception and into an unified system with guaranteed safety. The, our work addresses this by creating a closed loop architecture where fault detection directly constrains the decision making process. So, what is need of this? Our pipeline includes automated AI using YOLO, UNIT, and PPO, intelligent decision engine for selecting best panels, real-time monitoring and automatic shutdown, scalable architecture for large system. Also, the panels are ranked based on temperature, dust, and irradiance. Hotspot panel are automatically excluded. So system is both intelligent and safe. So coming to the working of our system then our system works as a continuous closed loop pipeline that integrates perception, data processing, and decision making. First, a thermal grayscale image of the solar panel array is captured. This image is passed to perception layer, where YOLO detects individual panel boundaries and unit performs pixel level segmentation to identify hotspot regions. Next, in middleware layer, that detected hotspot are mapped to the specific panel ID using spatial overlap. Each panel is assigned a fault flag such as hotspot or critical status. This information is then converted into a structured state representation, including parameters like temperature, dust, irradiance, and fault indicators. In the control layer, a PPO-based DRL agent takes the state as an input and selects the optimal set of panels to operate. And before execution, hard constraints are applied to ensure there are no faulty panels are selected. Additionally, the system continuously monitors temperature, and if panel exceeds the threshold, a reactive safety mechanism immediately shuts it down and activates the back. So, the architecture of our project. This architecture is designed as a three-layer closed-loop system that tightly integrates the perception and control. The first layer is a perception layer where thermal images are processed using YOLO to detect panel boundaries and UNIT to identify the hotspot regions at pixel level. The second layer is a middleware layer which converts this visual representation into structured data. It maps detected hotspot to specific panel IDs and generates fault flags such as hotspot and critical status of the panel. The final layer is a control layer where PPO-based DRL agent makes decision. The agent takes inputs like temperature, dust, irradiance, and fault flags and detects the optimal set of the panels. A key feature of our architecture is use of the hard constraint, which completely remove the faulty panels from decision space, ensuring the safety. So performance of our system performs very well. High detection accuracy, efficient panel selection, and fast response time. Most importantly, faulty panels are never selected. Efficiency remains high. So we achieve both safety and optimization. The system can be used in the large solar farms, commercial buildings, homes, manufacturing, drone-based inspection, which reduces its cost, then improves safety and automation. In future, we can use advanced AI models, deploy on edge devices, add predictive maintenance, use multiple sensor, build digital twins. This will make a system more powerful and scalable. So to conclude, we developed a hybrid AI system that combines computer vision and reinforcement learning. It provides automatic fault detection, intelligent control, and real-time safety. And importantly, it achieves high efficiency while preventing a faults completely. Thank you.
Hey, Michael, sir, any questions?
Thank you for your presentation. No questions from me.
Right, Sandeep, sir, any questions for him?
I want to know the limitation of the proposed model.
Yes, sir. So the limitation of this project is basically uh, first, it currently tested in simulation environment. So the real world deployment may introduce additional challenge like sensor noise and environment variability. The DRL model assumes relatively stable conditions, so significant changes in environment may require training. The accuracy of system depends on the quality of thermal imaging and the fault detection. So errors in the perception can affect decision. This limitation can be addressed in future work through the real-world deployment, improved sensor integration, continuous model updates.
Okay, thank you.
Okay, thank you, sir. Now, this is the last call for Marisela Pinagold Ortega.
Excuse me.
Hi.
Yes?
See,
I'm,
yes.
I'm Dhruv. I want to confirm that was my PPT visible?
Yes, sir, your PPT was visible until that table page. We could not see your conclusion slide, but I believe that is okay.
Okay.
Yes, Marisela ma'am, are you present?
Present.
Yes, ma'am. Please present your study on usability and accessibility on the website of the Inclusion, Social Equity and Gender Unit of the Technical University of Manabi.
Usability and accessibility on the website of the Inclusion, Social Equity and Gender Unit on the Technical University of Manabi. Introduction. Context. The Technical University of Manabi at Ecuador taught is inclusion, social equity, and gender unit continually monitor students, graduates, faculty, and staff with disabilities. Nevertheless, the website presents accessibility barriers that hinder its use by the community. These barriers are largely due to the gradual deterioration on accessibility tools since the portal was created. Aims. In the context, this study aims to evaluate the usabilidad and accessibility of the inclusion social, equity, and gender unit website using automatic evaluation tool for the principles. Methodology. Initial usability and accessibility evaluation of the baseline website. Problem identificación. Specification of functional and non-functional requirements. And the new website. Results. Problems identified. Images that alternative text limiting access for people, while low vision or blindness would rely on screen readers. Text as insufficient character and line spacing with increased visual fatigue during reading. The site uses an excessive combination of similar colors such as white and light black, which reduces visibility for people with low vision due to limited color constraints. The site does not provide subtitled videos which affects users with hearing impairments. The site lacks a sitemap and navigation bars with gender navigation and interaction. Requirements specification. Functional requirements. Alternative text for visual content. Create accessibility video players with subtitle of text descriptions. A site media accessibility tool. Non-functional requirements optimize size load time to no more than their second understand network conditions, ensuring compatibility with major browsers. Developed on the night website. The site automatically adapts to the user device and screen size, improving the browsing experience. And accessibility tools was added to support navigation for people with visual impairments of color blinds and prohibited features, improving interaction and shoot in figure. Educational videos describing words and expression in sign language were addition and organized alphabetical and shot in figure. Developed and the NUNSAT Cloras Equatorians. Comparison on the baseline website and the new website. The results muestra a significant improvement in the new website
Excuse me, ma'am.
compared with the baseline.
Manasala, ma'am. Hello.
Yes.
Ma'am, could you please speak in English?
وسعت conclusions. Among the main improvements are the addition of an accessibility toolbar responding the sign and the inclusion of Ecuadorian sign language glossary with facilitated navigation for people with visual and hearing impairments, starting the overall perception on the size accessibility. Reference. Thank you.
Michael, sir, any questions?
Actually, none, but the presentation was not clear. So I want to appeal to her against subsequent presentation in such an audience. Make effort, like our moderator have mentioned, probably practice before you come to present. Since we are presenting to an English audience, please make the presentation clear so that we can make meaningful contribution. Wish you the best. Thank you very much.
Sandeep, sir?
Yeah, same issue is there. So appeal to the next presenters to take care. Thank you.
Thank you. Kari Sai Vardhan, are you present, sir?
Yes, yes.
Yes, sir. Please present your study on evaluating explanation consistency of explainable machine learning models for heart disease risk prediction.
Is my screen visible?
Yes, sir.
Good morning, everyone. I am Karisai from Chandigarh University. Today I will be presenting my work about evaluating explanation consistency of explainable machine learning models for heart disease risk prediction. Heart disease is one of the leading cause of deaths worldwide, and early prediction is important for effective treatments. But there are many machine learning models that can help in predicting the heart disease accurately. However, many of these models provide black boxes, which are hard for doctors to understand to stress the models, which is why we need to use the explainable AI methods like sharp and line. But these methods provide the explanations, but doctors doesn't know whether they can trust these methods or not. So, so our research is to address this issue. Explainable AI methods like sharp and lame are used to interpret model predictions. However, the most important question is, do these methods give proper explanation? Currently, most of the researchers focuses on prediction or explanation, but not on evaluating whether these given explanations agree with each other or not. Our main objective of our work is first to compare the different machine learning models such as logistic regression, random forest, and multi-layer perceptron. Secondly, to apply the explainability methods like sharp and line. And thirdly, to measure these explanation consistency between these
Madam, I
methods.
think slides are not scrolling. Yeah, please check once.
Not scrolling.
Yes, yes, still on
It is
the.
switched on the first slide only.
Sir, could you try to reshare the PPT? Share that particular window.
How is it visible?
Yes, sir. We can see research objectives.
The main objective of my work is first to compare the different types of machine learning models such as logistic regression, random forest, and multi-layer perceptron for better accuracy, and secondly to apply explainability methods like sharpen line, and thirdly to measure the explanation consistency given by these explainable AI methods and provide case-based explanation. In this, I have used hard disease data sets that includes various clinical and demographic features, such as age, gender, chest pain, blood pressure, cholesterol, and other medical and other indicators. These target variables say whether the person has heart disease or not. Our, our methodology consists of several steps. First, we pre-process the data and split into training and test data, and then we train the multiple ML models such as logistic regression, random forest, and MLP, and we use a feature extraction on logistic regression and MLP, and which gives a results based whether the person has heart disease or not. Then we evaluate the performance using metrics like accuracy, recall, and finally we apply explainable AI methods like sharpen line for explainability and performance consistency analysis. From our results, random forest achieved best performance in terms of recall and AUC score, and logistic regression provides good interpretability with same performance. But MLP model did not show significant improvement despite being more complex and neural network method. Then we applied explainability methods. SHARP provides global view of future importance and gives explanation to the doctors, and LIME focuses on local explanation and explains individual predictions. Most important features identified include chest pain, number of vessels, and ST depression. The key contribution of our work is we evaluate whether the sharp and line provide consistent explanations, and we compare the important features identified by the both methods and measure their overlap. We observed moderate agreement, which means explanations are not fully consistent. This indicates that relying on a single explainable methods gives leads to faulty decision making in clinical process. In conclusion, random forest achieved best performance for heart disease prediction, and however, our study shows that explanation consistency is equally important for building trust in AI systems. Using multiple explainability methods can improve reliability in healthcare applications. Thank you.
Michael, sir, any questions? Sandeep, sir, any questions for him?
I have a question. You have compared the Lime and Sharp model, and the comparison you have shown, the results you have shown, they are very generic in nature. So my question is, are there any specific observation related to the problem statement you studied for the Lime and Sharp?
Sir, sir, uh, Sharp uses global explanation, sir, and Lime gives local explanation. Sometimes both are different types of mathematical models. Sometimes both give different explanation, which may cause uh, doctor to identify the problem more difficult. So we compare the both models. So both if the both explanation methods agree on the same thing, then the model gave accurate prediction. Otherwise, the more detailed human checking is required on that specific case.
Both of these methods have some limitations. So can you come up with some hybrid method which can have the advantage of lime as well as sharp? Whether you have attempted for that?
No, sir. Our our project is mainly so most of the projects right now are only giving whether they are giving accuracy or they are whether they are giving explanation. Our project brings uh, checking whether the given explanation is trusted or not. In future, we may add many explanation models and to check whether the given explanation is correct or not.
Okay, thank you. All the best.
Thank you.
All right, thank you very much, sir. Now we're done with all the presentations. I sincerely thank our authors for their excellent presentation and contribution in this session, and all your participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 11th version and all the previous 10 versions of the conference. We will be happy to have you in the 12th version in 2027. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Hence, kindly cooperate with the team of ICTIS 2026. I would like to thank our session chair, Dr. Michael David, for chairing this session. I am sharing a token of appreciation on behalf of Team ICTIS and Global Knowledge Research Foundation and partners. Thank you, sir, and please share a few concluding remarks for the presenter.
Yeah, I want to sincerely appreciate ICTIS for the privilege to attend this session and all our presenters. Thank you very much. Thank you.
Thank you very much, sir. I would also like to thank Dr. Sandeep Thorat for chairing this session. I'm sharing a token of appreciation on behalf of the team. Thank you, sir, and please share any remark.
I extend my sincere thanks to organizing committee. Overall, this session was very well planned. I congratulate all the authors for presenting their work over here. We have given certain suggestions. Many of them are in the beginning part of their research journey. So wish you all the best. Do some miracles and have some good contribution in the research. Thank you.
Yes, thank you very much, sir. Now, lastly, I kindly request everyone to please turn on your cameras for a quick snapshot of this virtual conference. All right, thank you, everyone. Have a great day ahead. Take care. Thank you. Bye bye.